When I first heard the theory I'm going to describe to you, it was told to me by, I think, a man that's normally considered the most brilliant scientist in the United States. And he was rather miffed that he hadn't come up with this theory himself and was explaining it to me. And I said, Dick, I've read about this before in science fiction. Isaac Asimov, the famous science fiction writer, in 1941 wrote a science fiction story about a star system which wasn't just binary like this one, but actually had 7 stars in it. And because there were 7 suns, there was never night on this planet. And every 5,000 years, though, there were simultaneous eclipses of all the suns. Darkness would fall on the planet. It was totally unexpected. The inhabitants were startled and disturbed and began burning down the cities to get light. And then the eclipses would reveal the stars behind. You know, you only see the stars at night or when there's an eclipse. And they were in the middle of an enormous galaxy of lots of stars. And the stars coming out in the darkness spooked everybody into burning down the civilization. And every 5,000 years, this civilization was burnt down and then recreated. This is more or less what I'm going to talk about today. So, as the preacher said, you know, tell them what you're going to tell them, and then tell them, and then tell them what you told them. I'm going to follow that pattern. So, I want to describe the structure of the talk. First of all, we're going to ask whether comets hitting the Earth can cause extinctions, and it's very clear that that is proven. We're going to ask whether Darwin's theory of evolution is right or not, and we're going to show that it's not. We're going to ask how to explain these evolutionary epochs that you learned about in high school, but nobody ever explained to you. Why are these epochs and eras changing? We're going to ask whether these evolutionary breaks are actually periodic, and we're going to ask what could possibly cause such periodicity, and then we're going to discuss Richard Muller's theory that a second sun in the solar system could cause such periodicity. I regret that Sam's introduction has scooped this whole thing, but that's my own scoop of it. Now, the most recent thing like this happened 100 years ago in 1908 in Siberia. In this area where the Tunguska event occurred, a rock from outer space didn't hit the Earth. It blew up in the sky. It leveled trees for hundreds of miles, and the sound was heard for 350 miles at the Trans-Siberian Railroad. If it had arrived 6 hours later, it would have destroyed St. Petersburg, but fortunately, it landed in Siberia. There was no crater because it sort of exploded in midair, but it had the power of a 10 megaton hydrogen bomb. So this was a small event. This is the most recent event. This was 100 years ago. It was seen as a kind of a bright sun moving across the sky, and 10 minutes later, the sound, the shock wave was so great that it knocked people off their feet. Now, 500 years ago, there was a meteor shower in China. I have an example of the meteor on that table, which I've brought back from China. And I want to say something about this. During the Great Leap Forward, Chairman Mao was told erroneously by someone that people could make steel in furnaces in the roadside. And he told all of China, make steel in roadside furnaces. It was a complete waste of time and a complete nonsense. But in the Yucatan region here of China, people knew that there were these iron fragments. This is one of them here. You can look at it after the talk. And they thought, well, we'll use that instead of just pots and pans were melting down to make steel. But they discovered they couldn't melt it down, so they called the scientists in Beijing and asked, what's going on here? We can't melt this down. And the scientists came out here and they said, oh, well, we know what that is. In our records, this was the great meteorite shower of 1516. Chinese keep very good records, so they knew that 500 years ago, these meteorites had showered there, and that's one of them there. So that was a shower of meteorites, again proving that rocks can hit us from outer space. Now, until 100 years ago, most of the scientists thought that the craters on Earth were volcanic craters. They didn't think they were caused by space rocks. But in 1906, this crater in Arizona, the famous Arizona crater, was proven to be the result of meteor impact and happened 50,000 years ago. This is the largest meteorite found at it. It looks very, if you look at it closely, it looks just like mine, only bigger. And this crater was caused by a outer space extraterrestrial rock that was only 50 yards across. But it caused an explosion of about 10 megatons and created a crater in Arizona 4,000 feet in diameter. That's almost a mile in diameter. You can see this man shows you the size of it. It's almost a mile in diameter. The rim is 150 feet above the desert, and it's 600 feet deep. So that's what a space rock can do. And this is the first crater that was identified as really being the result of extraterrestrial impact, which is what we're talking today. So it's only been known that this was possible, that these rocks were hitting for 100 years. Now, how did all this happen? Let's talk about debris in space and how the solar system was caused. The universe, you know, was formed 13.75 billion years ago. It took about 10 billion years before the Earth was formed. Most of the universe's history, there really wasn't any Earth around. There was originally a gaseous mass coming from a previous star explosion up there on the left, and it's gradually condensing. You see rings of matter there. The rings get sharper and sharper until pretty soon you have these planets, which are the result of accretion of debris into the planets, and the sun is drawing debris into the sun, and Jupiter, thank God for Jupiter, it's a very large planet and not far from us, it captures a lot of debris too. So by the time the Earth was formed, about 4 billion years ago, the bombardment of all these planets by debris caused by the initial creation of the solar system had pretty well vanished. And for a long time, people thought that was the end of the debris. But it was realized later that there was a late heavy bombardment that occurred from the time the Earth was formed until life began 3.8 billion years ago. And this late heavy bombardment was caused by the migration of some of the planets, the outer planets, Jupiter, Neptune, Uranus, Saturn, started moving further away from the sun. And this caused asteroids in the asteroid belt to move closer to the inner part of the solar system, where the Earth and Venus and Mars are, and created new rains of debris. So there was a lot of debris hitting the Earth until life was formed 3.8 billion years ago. So really, the first 9 billion years of the universe, we didn't have Earth as we know it now and didn't have any life at all. So so right now, we're sort of in the eye of the hurricane because most of the debris has been cleaned out. Now, in 1980, this man, Luis Alvarez, who's a Nobel Prize winner, he actually proved that the dinosaurs were destroyed 65 million years ago by the impact of a comet. And this was a mind-blowing proof for the scientific community. In the 1830s, there was a man named Lyell who taught people not to believe in catastrophism. It was considered a kind of a religious idea to think things could happen on Earth by catastrophe, like Noah's flood. And it wasn't considered scientific. So the scientists pretty well steered clear of any notion that catastrophe was doing anything. So they steered clear of the idea that comets hitting the Earth, causing a catastrophe, were a part of the problem. But this man, Luis Alvarez, a very brilliant man, he starts searching in the sediment that was formed all over the Earth 65 million years ago. What was in this sediment? He found iridium. Iridium is a rare metal like platinum. And it was found in concentrations in this sediment at 600 times the level that iridium would normally be found. So there was a kind of a ring around the Earth of iridium at the layer of sediment where it was 65 million years ago. And he knew that iridium is found in much higher concentrations in extraterrestrial objects. So this is how he proved that the dinosaurs had been affected by the strike of a comet. It takes a long time for scientists to agree to anything, but a few years ago, from 40 institutions, 99 scientists of all fields got together, and they all agree that Alvarez was right. So we now know that at least in one case, comet impact did affect evolution. It was a massive extinction of 75% of all species, including most plants. 95% of all living creatures may have perished in this disaster. Now, the comet struck in Yucatan. You see, here's the United States, here's Mexico. That's the yellow thing, that's the Yucatan Peninsula. That's where the comet struck. That's where the crater is, showing there. And this impact was of a rock about 6 miles in diameter, so sort of the size of San Francisco. And it caused a crater 110 miles in diameter. The explosion was 2 million times larger than the largest hydrogen bomb ever exploded, which was the 50 megaton bomb the Russians once exploded. So it was 2 million times larger than even the biggest hydrogen bomb, one bigger than airplanes could carry. So that's a lot of explosion. Now, what does that do? When comets hit, you get wildfires, you get darkness, you get tsunamis, you get cold and death. These are pictures of this rock hitting the Earth, the dinosaurs watching. You get extended periods of endless night. For a few months, you couldn't see your hand in front of your face. So what happens then? The plants die, and the dinosaurs, which ate a lot of plants, they die. Or the things they were eating, if they're carnivore dinosaurs, they were dying. So everything that depends on this was dying. The temperature fell below freezing. There was a 3-month period of darkness and cold. Birds, which are descended from dinosaurs, some of them survived, but most things did not. Tsunamis were thousands of meters high. Imagine a tsunami thousands of meters high. I mean, you know, that's miles high. And shock waves and earthquakes result, and volcanic eruptions. Well, we know that in 1823, Krakatoa erupted and produced dust in the sky. And in Vermont, there was a year without a summer, as Paul was talking about in Paul Smith was talking about one of his talks. So that was just Krakatoa. That was a relatively small thing. But if you have, you know, dust all over the planet, the sunlight can't get down to the Earth, you get a dramatic cooling, interruption of photosynthesis by the plants. And so it's a great disaster. And new species result from this because when the dying is over, all the natural predators of something that was usually held down can arise. And the whole environmental context has changed. And what happened in this case was the age of reptiles and dinosaurs turned into the age of mammals. You are here only because, not only because you wanted to get up at 9 o'clock in the morning, you're here only because the dinosaurs were wiped out. There were mammals during the reign of the dinosaurs, but they couldn't rise up. The dinosaurs lasted for 400 million years, you know. They weren't dying out because they were too stupid or too cloddish, you know, or couldn't compete with mammals. Nothing like that. They could compete with mammals. They were holding mammals down. You wouldn't be here if the dinosaurs had not been destroyed by this catastrophe. Now, you were told in high school that there were all these periods, epochs, and, you know, with weird names. There was the Precambrian period on the bottom, and then on the side, there's the Paleozoic era, the Mesozoic era, the Cenozoic era. And then there were these periods which were less dramatic changes in life than the eras, and then there were these epochs. But nobody, you probably didn't have the wit to ask your science teacher in the 9th grade, you know, so what the hell caused all this? You know what I mean? Well, why were these changes in life? Why isn't there just sort of a very gradual evolution? Why can you see changes? Nobody really asked that, see? And they didn't believe in catastrophism, so nobody was really quite sure. But we will see that these big changes in eras came at times of the biggest extinctions. Now, in 1977, two biologists, Fisher and Arthur, said something amazing. They said, we've been looking at extinctions of species, we're biologists, and they seem to have periodicity. How could that be? They thought it was periodicity every 30 million years. When you adjust for the way rocks were counted in those days, it turned out they were thinking of 26 million years. And 7 years later, these two biologists, Raup and this man, Sapkowski, Jack Sapkowski and David Raup, they looked at this and they also found periodicity. You know, an enormous number of species have lived since the world began, far more than we have today. Most species are extinct. They average about 10 million years. But these biologists, they looked at 250,000 species. And Raup told Sapkowski, let's find out, when did they get extinct? So they looked at the extinction dates for 250,000 species. I mean, I was asked when I gave this talk at the health center a few days ago, do they really have records in the ground for so many species? Apparently they do. So they began looking at this, and they found these. They found this periodicity. Let's look at this periodicity. Here are the extinctions. This is the period of years back to a mere 250 million years. So this is not all the way back to when life began, but it's about half of it. And now here are the rates of extinction. You see, these sharp points are periods where there was enormous extinctions. Now you see that of these arrows, the first three are really big. Then there's another big one, then there's another small one, then there's another small one, and then there's nothing for two of them. And then there's another one, and then there's another one. So it looks like if you were looking at this, you would say, wow, this is really something. Every 26 million years, see 10 times 26 million is 250 million. So these are spaced out at 26 million year intervals. And only twice wasn't there a large extinction. So something was happening. But the question was, what the hell could do it? A great mystery. And the big five major extinctions here, they define the really big periods that we were looking at before. This great dying, the last one, is called the Great Dying, 250 million years ago. 95% of all species died. To destroy a species, you have to really have a lot of destruction because it means not a single member of that species is left. To destroy 95% of all species, you got to destroy about 99% of all living things, you know. Well, you didn't destroy all the bacteria, but, you know. And after each one of these periods, life began anew and changed. And that's why you were taught those epochs and eras in high school. This is the way these 8 extinction events look when plotted on this graph. And you see the extinction events, they fall on this straight line, except there's 2 intervals, one at 7 and one at 5, where nothing happened. This is another way of looking at it, the periodic extinction rates for the past 250 million years. So half the statistical statisticians, you know, it's hard to persuade them of anything. Half the statisticians weren't sure there was periodicity, but half were, I'm sure. Now, Richard Muller is a friend of mine. When I was president of the Federation of American Scientists, he was one of the scientists on my ruling council, and he was described to me before I met him He wasn't as one of the most brilliant and wide-ranging scientists in the country. He wasn't a Nobel Prize winner, as Sam said, but he had, I was told, earned every prize except the Nobel Prize. And he had discovered many different things. Luis Alvarez, the Nobel Prize winner who discovered the dinosaurs had been destroyed by a rock, said he was the equal of the best broad experimentalist known in my career. Rich, who teaches at Berkeley, I asked him to come down here and give this talk, but he's working on climate change, and last month Scientific American had a 3-page write-up about him and his work on climate change, so he doesn't have time. But he discovered that the Milky Way was moving through space at 1 million miles an hour. He discovered image sharpness theorems for optics, new methods of dating, which were thousands of times more sensitive, an automated system to discover supernovas. He's a very wide-ranging experimentalist. If you go to his website, you'll see he's written a novel about Jesus Christ. You'll see that he's given a talk at Berkeley, famous lectures called Physics for Presidents. And so he's very good at explaining people, better than I am, explaining to normal people what physics is all about. And this book, Nemesis, is a brilliant, lovely, wonderful book about how he came upon this theory and the problems of getting it started. The 3 books that I'm referring to in this talk are all on that table, along with my meteorite, and you can look at them after the talk. So that's Rich Muller. Now, what was Rich Muller's theory, and how did this come about? Well, he was told about this periodicity by the biologists, and Luis Alvarez said to him, oh, well, you know, there seems to be periodicity, but we know that 2 of these were caused by comets, so they don't count. We'll have to throw them out, because comets, you know, that's something else. And Rich said immediately, oh, maybe they were all caused by comets. How do we know? So Luis Alvarez said, well, Rich, how could that be? And he said immediately, well, maybe we're part of a binary star system and don't know it. And maybe somehow, when the second star comes around, it brings disaster with it. And Luis Alvarez said, well, how would that be? And he said, well, it could perturb Oort's cloud of comets. So I want to discuss this and Oort's cloud of comets. This is not to scale. There's the sun and little planets around it, and then you see these little dots. That's Oort's cloud of comets. I'll talk more about that in a minute. Nemesis is the name he gave to the second star, if it exists, would be way out there, 14 trillion miles away, which is about 2 light years. And at the nearest point, 3 trillion miles away, maybe a half a light year. Now, what's a light year? Well, it takes light 9 minutes to get to Earth from the sun. Light travels at 186,000 miles per second. But because we're 93 million miles from the sun, it takes light 9 minutes to get here. Well, a light year is the amount of space it takes light to go in a year, not 9 minutes. So this Nemesis, at its further point, 2 light years away, it's a long way. So it doesn't ever get really close. And we're talking about something as small star and not very bright. So this was his theory, and he came up with this sort of in an instant. And he said Nemesis would destabilize Oort's cloud of comets. Now, this is not to scale either. The inner solar system is the eye in this. This blue stuff around here has got trillions of comets. What are they? This is the debris from the original formulation of the solar system. But this debris, way out there, is so far out that it doesn't get dragged into the sun by gravity, because gravity, goes off diminishes as an inverse square law. You get far enough from something, you don't feel much gravity. So it's so far from the sun that the sun doesn't pull it in. But it's not so far that it can escape. So these comets slowly go around in orbit around the sun from way out there. They're from 50,000 astronomical units That's 50, see that arrow shows 50,000 astronomical units? An astronomical unit is the distance of the Earth from the sun. So that diameter is 50,000 times the distance from the Earth to the sun, see? So it's measured in a fraction of a light year. So this stuff is wandering around. And astronomers have known for a long time that if a passing star, not connected to our sun, just passed by a few light years away, that the gravity from that star could perturb these comets and drag some of them into the solar system. And the astronomers knew things that Rich didn't know at the time, that passing stars could do what he immediately suggested could happen. But he was not predicting a passing star, he was predicting a binary system. 75% of all stars are part of a binary system. The idea of our solar system with just one sun is a rarity. It's not the norm. The norm is there's a couple of stars wandering around each other. Maybe not 7 like Isaac Asimov's story, but 2 at least, or 3. So this is very common. And Rich discovered that an astronomer, he actually was from my college, Swarthmore College, had once written an article saying, we could be part of a binary system and not know it, which was, of course, exactly what Rich was projecting. So they began to count. As a mathematician, I can only applaud that. And they said, well, there's about 10 trillion comets in this cloud. And only 1 in 10,000 would be kicked into the solar system. Okay, so that leaves about 1 billion. And this billion comets would come in over a couple of million years, about 2 million years. You see, it would come in when the star was at the near point of this elliptical orbit. And during that time, it would be perturbing Oort's cloud of comets, even though the cloud doesn't go out to the, anywhere near out to the orbit of Nemesis. But it's at this point that you'd have this perturbation. So according to Rich, during the 2 million years that Nemesis would be nearest our sun, you see it takes 26 million was his theory to get around this whole place. It would come back every 26 million years. But during the 2 million years that it was close to the sun, if the dinosaurs looked up, they would see comets every night. The sky would be blazing with comets. Of course, not all of them would hit the Earth. The Earth is a rather small target. But according to their calculations, 1, 2, or 3 would. And so this was the theory. And as you will see, anyway, Luis Alvarez, after looking at the other theories, I'll mention in passing some of the other theories. Luis Alvarez, the Nobel Prize winner, said, I'm now fully convinced that the periodicity that paleontologists discovered in the mass extinctions is real, and that Rich's Nemesis theory is the only plausible explanation. So at least he sold his pal, Luis Alvarez, on this theory. And so this was Oort's cloud of comets. And how big is Nemesis? Well, Nemesis, according to Rich, would be like a brown dwarf. See, that's the sun on the left. That's Earth down here. That's Jupiter, much bigger than Earth. And then these are stars, a brown dwarf star, a low mass star. Not all stars are as big as the sun. This brown dwarf or a red dwarf, it might not be much bigger than Jupiter. It might only be 9 times bigger than Jupiter, you see. And because they're small, not all of them have fusion. You know, they're not blazing light. You may have to see them in infrared. And so you wouldn't know they were there. It's not like it's not like we woke up this morning and missed the fact that there were 2 suns out there, not 1. You know, people who want to get people to come to their talks talk that way, but it's not really like that. So anybody leaving early will have their grade reduced. They all say they have to leave. What can I say? So anyway, they're going to miss the best part. So that was the theory. And the star that Rich thinks is the one, which is a red dwarf, they're in the star catalogs. We know where the stars are. What we don't know is where are they going? No one has checked to see, are they moving around us? You know, that was something nobody had thought of. So, and that's a difficult thing to figure out. Now, one of the things that Rich's theory does is it deals with an objection that the paleontologists had about punctuated evolution. Some of them said, well, you know, we've looked at these bones, and these dinosaurs, they did not die all at once, being like that, you know. We see that some were still alive, you know, 1 million years later or something like that. But according to Rich's theory, there would be a 2 million year period during which there would be rains of comets. So you could have the dinosaurs being destroyed in a series of impacts over a period of time. And it has since been discovered that there are craters from 65 million years ago discovered in the same latitude with the one in Yucatan. And so they may have struck at the same time. And they've seen when a comet struck Jupiter that it split into pieces, and, you know, and there were comet strikes over a period of time. So the astronomers know that the comets can come at different times. These craters that are said to be about the same time, they may have been 300,000 years apart, for example. The dating of these craters is not exact. So you could have a comet hitting Yucatan and then a comet hitting in the Ukraine 300,000 years later. So the dinosaurs, some dinosaurs might have survived one disaster only to die in the next disaster. So it could explain punctuated evolution. Now, once the Alvarezes and Rich started getting going on this theory, they began looking at craters. They thought, wow, you know, craters, let's see if we can see periodicity in the craters if we're going to think of meteors and comets destroying all these things. So they started looking at all the craters. These are the big craters around the world on this map. And they found 88 impact craters. The 13 largest and best dated ones did show periodicity. And Rich says, our analysis has proven to be rather robust against changes in the data set. You know, in other words, you can take some of these out and put in some of these, you still get periodicity. And half to 2/3 of the craters come from comet showers. In other words, they're not just predicting periodicity in comets. They're discussing periodicity in rains of comets every 26 million years. And they're seeing evidence for that. And then Rich and Saul Perlmutter discovered that you could figure out the age of meteorites by their exposure to cosmic rays. How long had they been exposed to cosmic rays? Please don't ask me about this at the end. And they showed that as far as the last 3 major extinctions are concerned, the meteorites caused by comets, when you look at them, are distributed in such a way that they seem to support periodicity. That is, lots of meteorites, like my Natan meteorite, are falling at the time of these comet showers for the last 3 extinctions. So this was the first evidence for comet storms that wasn't based on terrestrial effects. This was based on aging of the meteorites in outer space. Now also, Raup looked at reversals that are recorded. The rocks record reversals in the polarity of the geomagnetic poles. These magnetic, you know, the North Pole reverses, become the South Pole, stuff like that. And this is normal today, and this is reversed. So they found, Raup found, they looked at 296 reversals. And they found peaks in the rate of reversals about every 30 million years. So in the magnetic history of the planet, they also seem to find periodicity. And then Muller got some space rock, a gram of it, from the astronauts. You know what I mean? He applied as a scientist, and they gave him a piece of the rock brought back from the Apollo missions to the moon. And from this gram, he figured out a way to date how long ago a particle was melted. And he showed from that the moon has been getting barrages of intense bombardment So this means that this is further support for that, because of course any bombardment by comets of the Earth would also be bombarding Mars and Venus, and they're also in the inner solar system, and these comets are screwing everything up in the inner solar system. So Rich said the evidence clearly shows the moon has gone through spells of relatively frequent impacts and others of reduced intensity. So there is more evidence for comet storms. Now, there are other explanations for bombardment. At the very beginning, people talked about, well, they said, well, our sun and solar system are passing through the Milky Way galaxy every 31 to 33 million years. Maybe this has something to do with it. And they also said our solar system is going up and down below and above the galactic plane. And maybe this has something to do with it. And maybe the sun is erupting periodically. And maybe an interstellar cloud of dust and gas is disrupting the Oort's cloud. And maybe we're passing through spiral arms of the galaxy. There were lots of theories. That's the way science operates. But as Luis Alvarez said, the most plausible one was Rich's theory, and some of these have been discredited. There is a theory, there's a new planetoid that's been recently discovered that is further out than Pluto, called Sedna. You see it up there? It's only 800 to 1,000 miles in diameter, and it has a very weird orbit. And it's way out beyond Pluto, and the astronomers say, we don't know what keeps it in that orbit. Maybe some unseen other gravitational influence, which of course could be Nemesis. And in any case, Sedna is a piece of the puzzle, but nobody knows how to connect Sedna to periodic perturbations of the Oort's cloud. But it's floating around in the Oort's cloud, and or at least way out there, and it could perturb it, that's for sure. So they're searching for Nemesis now. What you have to do to search for Nemesis is you have to take photographs of these stars, which look to us as if they're fixed. And then you have to photograph them 6 months later when the Earth is on the other side of the sun, so you're getting the stars from a slightly different angle. And then you got to see from that, has it been moving, and how has it been moving, and is it possible that it's been moving in a way that would be in orbit around us? So that's what the astronomers are doing. They've automated a system that will automatically take pictures of these stars at 6-month intervals and try to see whether they're moving. So they're trying to do this with 5,000 red stars in the northern hemisphere. And so the data will soon be in on 3,000 stars. Muller thinks it's hidden in Hydra. I'm not sure why. And in a few years, it's believed that they will know. I called Rich and asked him about this the other day, and he said he thought within 5 years they would know. This is really something, because, see, this theory was formed in the 80s, early 80s, you know. And very little has happened in the intervening period. And Rich has been encouraging astronomers to look for this star for a long time. If they find this star, you know, this will be the biggest thing since Isaac Newton and Albert Einstein. I mean, this will change people's ideas about everything, and I will talk about that further in a minute. Now let's talk about Darwin. The reason Darwin's theory is, I put it to you, incomplete, is because Darwin only works between the storms of comets. In other words, you have survival of the fittest and gradual adaptation to the environment and all that, so long as the environment is stable. But when a comet hits the Earth like that and there's darkness for 3 months, if you survive that, you're lucky. It means you happen to live underground. You didn't have time to adapt. This is happening in a split second as far as evolution is concerned. So it's not just genes and adaptation and survival of the fittest that struck evolution. The dinosaurs were wiped out, and then the mammals came to the fore because the mammals were lucky that the dinosaurs were gone. And at the time of the Great Dying, that big dying of 250 million years ago, the trilobites had gotten there first, and there were zillions of trilobites, those little creepy trilobites. And nothing could have broken through, you know what I mean? Getting there first is an important part of who controls things. But those trilobites were beaten to hell by this great dying. So evolution has been benefiting from these comet strikes. It isn't true that the dinosaurs were too big and bulky, you see, that the mammals were clever and they, you know, outwitted these dinosaurs and evolved from them. Nothing like that at all. Stephen Jay Gould, they overlapped, mammals and dinosaurs overlapped for about 100 million years. And Stephen Jay Gould, the paleontologist at, now dead at Harvard, he said, why are we here? Because the dinosaurs disappeared, not because the mammals outcompeted them. In fact, this idea is now becoming so understood that if you talk to people searching for extraterrestrial life, the SETI group, scientists looking for extraterrestrial intelligence, they first thought, well, we got to look for solar systems that are like the Earth. You know, that's where we came from. You know, it'll probably be like that. Look for a sun with a planet not too far from it, you know, and maybe a planet like Jupiter that will fend off debris by capturing it, you know, so let's look for that. But actually, when they start understanding this, they start thinking, you know, maybe we need to look for a more complicated solar system. Because maybe only in a more complicated solar system, when weird things are happening, can intelligent life break through from unintelligent life. And maybe it doesn't go forward in a normal, you know, graduated, sensible way. So now I'm coming to where do things stand. This is the tell them what you told them stage of this talk. That mankind is an accident of nature, I consider established. If you want to think otherwise, you got to believe that God started the universe 13.7 billion years ago, waited 10 billion years for life to start, and then life evolved, but was dramatically intertwined with enormously complicated astronomical accidents. Unless you believe God sent the comets to kill the dinosaurs for their sins. Otherwise, this is a very accidental thing, and it's hard to see that mankind is not here as a beneficiary of it. That Darwin works only between storms, that seems very clear to me in common sense. That there are frequent extinctions occurring on Earth is very clear. We've seen 8 or 10 of them. We saw 8 between 250 million years and now, and there were 2 really big ones going back to when life began. One at 330 million years ago, and one at 440 million years ago. And I believe there was probably one at 570 million years ago when life really got started. So I believe there were maybe 10 of them. I think they're likely caused by comet impact. I mean, if you ask the people that don't believe in catastrophe, they'll say, well, maybe it was climate change. You know, the climate changes and things like that. But the abruptness of this and the plausibility of this and the fact that we know it for the dinosaurs and that we see traces of the stigmata for an impact on a lot of the other extinctions. Not enough to persuade all the scientists to go for it. You know, some iridium, some stectites, some quartz shock rocks, and things that, you know, the scientists know come from impact. But only the dinosaurs, and I think one other, are really reached a consensus of scientists. But I don't see any other competing plausible hypothesis, as Louis Alvarez does not. And is a second solar system star possible? Well, Raup, the biologist, wrote a second book. He's got 2 books over there. One of them is on extinctions. It was written 20 years ago. He said, well, the astronomers don't really believe in this because they've never seen a binary system with stars so far apart. And they don't consider it stable, and computer simulations show it's not stable. But Rich, who is as good as these other guys in this, his position is that it isn't stable, but that it's there for 1 billion years, which is 40 revolutions of Nemesis. And he thinks that these 2 stars, the big one and a small one, were close together at the beginning, and they're gradually being pulled apart, sometimes by the gravitational influence of passing stars, and that Nemesis may be getting further and further away, but that and so the elliptical orbit may be busted into a hyperbolic orbit and may wander off, but for 40 orbits, it's still there. So, and so I don't, Raup's book on extinctions is the most recent thing I've read on what the scientific community knows, and Rich is not able to be here to explain to you fully what the consensus is, but I can tell you, science being what it is, when they find it, everyone will say, I knew that. And when it isn't found, they'll say, I question it. So that's the way science operates. I am a mere mathematician, so I'm telling you, this is pretty clear. Now, when I tell this story to people, they say, what, be worried? When is Nemesis coming around again? I say, well, 15 million years from now, because the last pass was 11 million years ago. Oh, they say, my life expectancy is not nearly that. I'm going back to sleep, which is why, of course, this room is rather well full, but not overwhelmingly. And so they're not worrying about 15 million years away. And as far as the next pass of Nemesis is concerned, they're right not to worry about that. And I wanted to show you, what does 15 million years really mean? The evolution of man has not stopped. It didn't stop when people started building villages. You know, under social and cultural influences, amazing things are happening in human evolution. So this is not over. Now, if we look back for 15 million years, we're back to, if you look at this, 15 million years ago, the orangutans, the gorillas, the chimpanzees, and the humans were, well, let's see, at 15 million years, the gorillas, the chimpanzees, and the humans had still not broken off. And it was a little after orangutans separated. So 15 million years from now, we won't have 4 legs and a tail or something. The gorillas still have 4 legs, and the chimpanzees, we won't be that different, but we will be very different. And our psychology will be very different. And our perspective will be very different. And mankind might die out through what's called soft extinction by then, which means people might decide they were not that interested in having children, in which case they would all die out. In fact, if you look at the demographic revolution, the richer mankind gets, the fewer children people want to have. And if you extrapolate that, people won't last 15 million years. Already in the developed world, population decline is seen if you leave out immigration. So anyway, 15 million years, a long time ago, and you don't have to worry about that. Mankind may perish for many other reasons. Nuclear war, which I spent 40 years worrying about, is still a possibility. And plagues are a possibility, and a sun eruption, and who knows what. But this still leaves the final question. Nemesis aside, will humanity be destroyed by some space rock? Now this is where this very brilliant book, Extinction by David Raup, which I have a copy of over there, is worth consulting. He addressed this question. He said, these Tunguska-size events, which you saw in Siberia, that's a rather small event, didn't even make a crater, they come about every 300 years. So you could lose St. Petersburg if it happened to hit a city. Most of the time it'll hit the water or Siberia or something. But if it hit a city, you'd lose the city. Now, 1 to 3 craters, about 20 kilometers, occur every million years. In other words, these are big rocks. Every million years, we can see 1 to 3 of these big rocks. Now, these are civilization-destroying events. In other words, they might not kill every human being, but they would set civilization back for thousands of years. And it would be very hard to come back, because we produce this civilization by looking for very cheap sources of energy, like oil bubbling up out of the ground or whales for sperm oil. You know, gradually we got technology to go deeper and find other sources of oil. But when you come to an Earth where the technology is gone and most of the people are gone, and you don't have this rich environment to live off of, mankind would have a very hard time restarting. So there'd be a very long period of dark ages. So these civilization-destroying events, Raup says, occur about every 300,000 years. Now, he can't be too sure about these estimates, so he thinks it's somewhere between every 10,000 years and every million years. And probably the number is every 300,000 years. Now, that's a big difference, of course. You know, if it's every 10,000 years, a person who lived 100 years would have a 1% chance of having it happen in his lifetime, which is the risk he has of being electrocuted by an electrical failure, you know. So it's not totally insignificant. We protect against those things. Of course, if it's 1 in a million years, then his chance of living during a time of such destruction would be very small. It's somewhere in between those two. So what's going to happen? Here's my theory. In cases like this, usually the small thing will happen before the large thing. That is, you'll have another Tunguska event, which comes every 300 years, before you have a civilization-destroying rock. That's the probability. That's what you'd bet on if you went to Las Vegas. And so it's not a certainty, though. I mean, a big rock could hit tomorrow and blow the Earth into 3 parts. We cannot guarantee against that. But, and by the way, we're looking all the time to see if a rock will hit the Earth. We take pictures every 45 minutes. And we look to see if these pictures, anything has changed in those 45 minutes to see if something is coming at us. If it's coming directly at us, even that picture might not show, because if it's coming directly at us, 2 pictures might not make that much difference. So these rocks appear without much warning, and one of them, last month, went between the Earth and the Moon. You read about it in the papers, and arrived without much notice. So we were lucky. It's a miss. So we are watching for it. But we're not spending a lot of money on it. But if a Tunguska event occurred, like 100 years from now, or 200 years from now, a city was lost, Big Bang, then mankind would bestir himself. They'd say, this is a real danger. We got to put some money into an orbital system that will be able to track things really well and look more at this more closely, get more warning, and in particular try to figure out ways to use missiles to shoot them down or deflect them. So with this kind of time scale and with the rate at which technology is improving, I think we have a very good chance, overwhelmingly good chance, that by the time our attention is drawn to this, and by the time that we focus on it, we'll have the technology and the ability to protect the Earth to a much greater extent than we have now. So I don't think civilization will be set back by a space rock 300,000 years from now. I'm not at all sure mankind will be around 300,000 years from now. And according to some theories, which I have some sympathy with, mankind and machines will have merged together in very weird ways, and society will be a very, very different thing. But in any case, space rocks, that's the thing. That's my talk.